Okay, we're going to take a look at capacitors here. We have 5 capacitors, C5, C4, C3, C2, C1. And I've got the multimeter set in the capacitor mode, and it's reading 109.4 nanofarads. And I would proceed down and measure each one in turn, and they should be fairly close to that number. So you can see this. So the second one is also there. Now what I want to do is put 2 of these in series so you can see what happens. So in series, we're dealing basically with one path, and have a green wire here so you can see it a little better, connecting the 2. And so I'm going to put one lead in here and the other lead there. And in series, capacitance goes down because I'm increasing the distance between the first negative plate and the last positive plate. So if we take a reading here, you read 53.2, so it went down by half, which is about what we figured. Now, if we, on the other hand, put them in parallel, what we're going to see is that the capacitance should go up because we're effectively increasing the surface area. So to put them in parallel, and I'm going to use a blue wire over here, I'm clipping here and here between 1 and 2. Like so. So you can see the blue wire, you can see the green wire here. Put the board in place and take the reading. So I've got one over here on this side, and I'm going to put the other one on the other side over here. And I should see it reading about 200 if I'm correct. And I'm reading 218, as you can see on the scale. So in parallel, capacitance increases. In series, capacitance decreases. In parallel, capacitance adds. In series, it adds reciprocally. So I'm going to repeat this. I'm going to put up to 5 in series, and I'm going to put up 5 in parallel. Using the multimeter. The ability to measure capacitance with a multimeter has only been for relatively inexpensive, I mean around $100 to $200 type equipment, in the last 10 years. Before that, we had to use a setup using what we call a ballistic galvanometer, and I'm going to go ahead and show you that setup.